In this video, I'm going to explain functions in modeling, and the first objective in this unit is graphs of rational functions. Now, graphs of rational function, I'm going to start with one example and then we find everything we need to know about the rational functions. For example, I have a function f of x equal 9 over x minus 10. This is a rational function, you guys can tell. And then the question is asking, what is the domain of this rational function? Now, domain on the function, if we have a graph, then we look for the x-axis where my graph is going on x-axis. But if we don't have a graph, then we have just a function. Then how do we find domain? For the domain, always make sure that the top portion, the numerator, doesn't get affected. For example, if I have 9 minus x in this case, for example, then any number I can plug in 9 minus x and I will be getting some numbers, right? For example, if I get 9 minus 0, then my answer is 9. So I have some y value there. I got my y value. If I plug in any other number, like for example, if I plug in 9 minus 9 is 0. So 0 is a number, so it's not doing anything. Domain is where you get something undefined, like I have a number in this is not acceptable in domain, and you have a negative in the square root is not acceptable. So these are the things not acceptable in the domain, right? So if I plug in any number up here on the top, just the top portion I'm talking about, numerator, then I'm not getting undefined, because undefined means 0 in the bottom. This is not a square root. I'm not getting anything in the square root like imaginary number. So the top portion is okay most of the time. We don't pay attention to the top one. But the bottom domain, you're going to make this bottom portion equal 0. I will get x equal 10. Now this x equal 10, and I have to give them a domain. This x is a domain, so I'm going to draw a line, and I call this a sign chart. And that's a 10 up here. For example, pretend that's a 10. So you pick any number here on the left side of 10. I will probably pick 0, and I will plug in this 0 in the function. When I plug in this 0 in the function, you know I'm getting 9 minus 0 over 0 minus 10, which is 9 over negative 10. Do you see I am getting some y value? Like there is no, this y value is not undefined. This is nothing there. We are good. We are getting y value and it's negative, which means this side, anything you pick on this side, it will work. Now let's pick 10 and plug it in the function. If I plug in 10 in the function, you know I'm getting 9 minus 10 over 10 minus 10, and I'm getting negative 1 over 0, which is undefined. This 10 doesn't work. Then I'm going to pick anything on the right side of 10, which means I'm going to pick f of 11, plug in 11. 9 minus 11 over 11 minus 10. This is going to give me negative 2 over 1. And I am getting some y value, so I'm okay here, right? So we are good. Which means from the domain is from negative infinity. This is negative infinity. You guys know that negative infinity, that goes positive infinity if I have a number line. So from negative infinity, and make sure negative infinity is not a real number. So, and you guys probably already know, if we have parentheses, it means the number is not included. Or I have these signs for inequalities. If I have brackets, then it means it's that number included, like it's a closed circle, okay? So I'm starting negative infinity, and negative infinity is not a real number, so it's always going to be a parentheses. 10 is not included either, because 10 doesn't work, so this is also parentheses. Then from 10 to positive infinity, again, I'll just put u there. I'm starting 10 to positive infinity. Again, none of these things are included in there. Okay, so infinity always not included because it's not a real number. This 10 is not even working for this because I'm getting undefined, so it's not included, and that's how it goes. So this is my domain of the function. Now let's figure it out how to find the range of the rational function. So that was domain. Let's talk about range. Range means a y value, right? And I have the same function. For example, I'll make it up 9 over x minus 10, the same thing. I just changed it a little bit. So this is my range. For the range purposes, again, if it's a graph, I can easily tell, oh, range is y-axis, I'm going top and bottom, but it's just a rational function. How would I find something algebraically like that? So you are, for this purposes, you are going to switch x and y's like we used to do for inverse functions. So this is f of x, a y value. I'm going to change this to x. 9 over, this x is going to switch to y. And then I solve this for y. This function I solve for y. Now always make sure when you have fraction on one side and you don't have a fraction on the other side, always make both of them fractions and cross multiply, because equal means that's a proportion. You can do the cross multiplication. So if I cross multiply, then I got x, y minus x, 10x. I multiplied x with y and I multiplied x with 10 equal 9 times 1 is 9. Now let's solve this for y. So if I solve this for y, I'm getting xy and move the 10x, like add 10x both sides. So this is going to give me 10x plus 9. Now get rid of this x. So we divide x and we divide x everywhere. So I got y by itself. It's 10x plus 9 over x. Now this is a y and that's a range, right? So if you can tell, it doesn't matter what I do on the top, it's not going to change anything, but the x equals 0 is not allowed because it's going to make the function undefined. So the range is all the real values except x is equal 0. So that's my range, and that's how you find the range. Okay, let's talk about intercepts. The intercepts, for example, X intercept means, if you want, you can take notes or pay attention, and this is the stuff that's just the review that I'm doing. X intercept means when y is always going to be 0, and make sure when they use the word X intercept, just write in as an order pair like that, then you won't forget that I'm talking about y0. Y intercept means when you plug in 0 for x, you will get y. X intercept, you plug in 0 for y. Y intercept, you plug in 0 for x, and you will get these x intercepts and y intercepts. Okay, let's talk about vertical asymptote. Vertical asymptote. You know, asymptote means when the graph doesn't cross the asymptote, like the vertical asymptote, it's not going to cross the graph is not going to cross the vertical asymptote. For example, if I have this graph right here, so if I pretend the vertical asymptote is -5, right there, -5, then you can tell the graph is going along that, and +5 is also vertical asymptote. Graph is going along this, but it's not going to cross the vertical asymptote. So vertical asymptote, and how do we can tell in the graph there is vertical asymptote, but we can't tell how we can tell in the function that we have a vertical asymptote. So in this case, vertical asymptote, always make, okay, not make, before that, solve the problem. Solve the problem means like factor out, do the common factor or any kind of factor, quadratic or cubic or any factor. Then do the cancellation, like if there is something to cancel out, then you cancel. After, at the end, when you solve the problem and you can't do anything else, then make denominator equal 0. And this will give you vertical asymptote. Okay, and I'm going to give you example for this, so don't worry. I'm just giving you definition really quick for that. Then we are going to talk about end behavior. What is end behavior? End behavior is like, for example, look at this graph. The graph is going in this direction, this portion is going in that direction. That's the end behavior of this. Where this one going? This is going towards negative infinity. Where this is going? This is going towards positive infinity. This arrow means it's going continuously forever. So negative infinity, positive infinity. So what we do, if this is going in this direction, that's going in this direction, we can tell there is a horizontal asymptote, right? Because it's not crossing that, it's going in the direction straight, this going in the direction. So we can say X, this is how we talk about the end behavior. We can say X is approaching negative infinity, then Y, or you can say, okay, let me do it. Then you can do f of X is approaching 0. You can tell if it's going in this direction, then I know my Y value is going to be 0. Because it's not crossing this x-axis. The same thing goes for that one. X approaches positive infinity, then my f of X is approaching 0. This arrow means approaches. So this is how the end behavior means. This is how this works. Then we have points of discontinuity in horizontal asymptote. Let me give you an example, and then we go from there. Before I go for the examples, let me tell you about the horizontal asymptote. How do we find horizontal asymptote? We already know the vertical asymptote because we make the denominator equal 0 after I solve the problem. Horizontal asymptote, it's going to be something like, for example, I have a rational function f of X. This is my function a of X, and the exponent on this is m. This is my bx function, and the exponent on top of this is n. Just pay attention here, okay? So I have some rules that you have to memorize it. If this exponent, the top exponent is equal to the bottom exponent, then it means my horizontal asymptote is my coefficient. Whatever the coefficient is for the top and bottom, that's your answer. If I have m less than n, like this exponent is less than that one, then my answer is 0. If I have m greater than n, then it means no horizontal asymptote. Okay, this is what the definition for it, and like I said, I'm going to go and give you example for each one of them. Then we have oblique asymptote. Oblique asymptote means this is not parallel to x-axis or y-axis. It's going to be oblique. It means m, like that exponent value m, exactly 1 greater than n. For example, if m is 2, then n is going to be 1. If m is 4, then this is going to be 2. So exactly 3, exactly 1 greater than n. And how do we find the oblique asymptote equation? It's going to be using syntactic division. Syntactic division. I have detailed videos on syntactic division and long division, so you guys can watch that. Okay, so let's try and do the examples. And I'm going to go back and forth to show you how all of this works. Example number 1. Okay, let's not do this. Example number 1. For example, I have f of X equal 36 minus 5x minus x squared over x squared plus 11x plus 18. So the question is asking, find the x intercept. Find the x intercept. Okay. and then find y-intercept, then find vertical asymptote, find horizontal asymptote, and then find a hole, and I'm going to explain that too. Okay, so if I'm looking for x-intercepts, then I know x and y is 0. So I plugged it 0 for y right here, and I put this all in here. I'm supposed to put this in order so we can do it easily. Order means the exponent, the square x is gonna come to the front with the sign. This is minus 5x, and then we have plus 36. Here we go. Then I have a 0. Always, like I said, one side is fraction, another one is not. Make it a fraction, cross multiply. So this whole thing turns 0, but that one is there. Negative x squared minus 5x plus 36 equal 1. This minus sign is not 1, 0. This minus sign is kind of bothering us because I won't be able to do the, I can, but it's going to make it harder. So let's get rid of this, move to make it common factor. So I got x squared, this one turned to 5 plus, and this one turned to minus 36 equals 0. Okay, now what else I can do here to find the x-intercept, which means I need x values. So I'm going to factor out. This is a quadratic, and then I'm going to factor out. If you don't remember your factoring, please comment below and I will explain. This is 2x's, and that's 36, which means 9 and 4, right? So if I subtract 4 from 9, I'm going to get 5, so I'm okay. Where the subtraction sign goes with the 4, because since this is positive 5, when we subtract, I should have a bigger number with the bigger number should have the sign. So let's factor out. I'm going to keep that negative up there, by the way. So I have x plus 9 and I have x minus 4. Done. And then I have this equal 0, right? Now what we can do, minus sign, leave it. I'm going to go x plus 9 equals 0, and I'm going to go x minus 4 equals 0, right? So if I do that, I know I'm going to get x equal, okay, like this, right? So if you want to distribute this negative already, you can go ahead and do it. It's going to give me negative x minus 9 equals 0. This is going to give me negative x plus 4 equals 0. This is going to turn negative x equal positive 9. This is going to turn negative x equal negative 4. Then I got x equal, to get rid of this negative, I got negative 9. To get rid of this negative, I got x equal positive 4. So these are my x-intercepts. You can write it as an order pair. X, for example, it's going to turn negative 9, 0, and I have 4, 0. And these are my x-intercepts, both of them. So my x-intercepts are right here. They are negative 9, 0 and 4, 0. Done. Then we look for the y-intercept. How do we get the y-intercept? Y-intercept means when x is 0, right? Y-intercept means when x is 0 and we find the y. So I'm going to plug in 0 for every x I have in there. If I do this, you guys can tell, if I plug in x as, okay, let me write down this question again up here to get the y-intercept. It's going to be f of x equal negative x square minus 5x plus 36 over x squared plus 11x plus 18. So I'm going to plug in 0 for x. So f of x is going to stay as it is. I got negative 0 square minus 5 0 plus 36 over 0 square plus 11 0 plus 18. Everything turns 0 except 36 over negative 36, actually, not positive 36 over 18. And my answer is going to be 2. So my y-intercept is 2. So my y-intercept is 0 and 2. Done. Then we have to look for the vertical asymptote. What did I tell you about the vertical asymptote? It's right here. Vertical asymptote, solve the problem, factor out, do the cancellation, and make denominator equal 0. And that's exactly what I'm doing, the 3 steps. Okay, the same question. I'm using the same question. It's f of x equal negative x squared minus 5x plus 36 over x squared plus 11x plus 18. Now again, since I'm factoring out top and bottom, I want to get rid of this minus, so this turn positive and this one turn negative. Okay, let's factor out. The top portion, f of x equal, the top portion is this negative stays, and I have x plus 9. I'm going to make it bracket so I know this negative goes outside. X plus 9, and I got x minus 4. We already know that, and I showed you how to get this x plus 9, x minus 4 right there. So I got that. This one was already done. Now let's do the bottom ones too. So this one is going to give me x plus 9 and x plus 4. Or no, 2. 9 times 2 is 18. There you go. Then you can tell x plus 4, x plus 9, x plus 9 cancel out. That's what I'm talking about, cancellation. If you don't have cancellation, like if there was no x plus 9 that they are canceling out, if it's not, then we're going to leave it alone, and then we can say, okay, vertical asymptote, 2 of them. We didn't make this equal 0, make this equal 0. But since they are canceling, I'm left with negative x minus 4, and I got x plus 2. Now I can cancel it. So now I'm going to make the denominator equal 0. So x minus 2, x plus 2 equals 0. The denominator, I got x equal negative 2. So my vertical asymptote is at x equal negative 2. So my vertical asymptote is x equal negative 2. Now let's do the horizontal asymptote. Okay. Now, horizontal asymptote is going to be, we are going to use the rules, the m and the n rules, which is right here. This is horizontal asymptote. The top portion is m and n. So we have to look what exponents we have in this one. Okay. So in this question, it's right there, right here. And if you guys pay attention very closely, that's where I'm going, horizontal asymptote. Okay. You don't have to solve for this. Now, what is the greatest degree on the top, like the exponent? So this is the term with the greatest degree, the square. This is the term with the greatest degree, the 2, right? This is greatest degree, that's the greatest degree, this is 1, this is 1, so of course. So do you see the m exponent, the top exponent is exactly the same as the bottom exponent. Like the m is equal to and the n is also equal to. Like this is, for example, m, that's n. So they are equal to 2, which means if m and n are exactly the same, then what is the horizontal asymptote? The coefficient is the horizontal asymptote. So the coefficient means what? What is the coefficient here? 1. And what is the coefficient here? 1. So my answer is negative 1 over 1, which makes it negative 1. So my horizontal asymptote is negative 1, which is kind of really easy for that. That's a horizontal asymptote. You just have to check the greatest degree on the top, greatest degree on the bottom, and use your properties like this. Use your steps like this. If the top and bottom, the degrees that you picked, the greatest one, they are equal, then coefficient. If the top is, like for example, for this one, I can give you example. If x is 1 and then I have in the bottom x squared, then do you see the m is less than n, like the top is less than 1, the bottom one, then it means the horizontal asymptote is 0, which is y equals 0. If that's the case, like I have x2 for this one, if I have x2 like greater than the bottom, like, or make it 3, this one is 1 in the bottom, then no horizontal asymptote. That's what I mean by degrees m and n, the exponents. Okay, we finished the horizontal asymptote. Now the whole. What is whole? How do we find whole? In the whole, you make sure you always do the same process like we did for the vertical asymptote. You solve, you do the cancellation. Cancellation is the whole. What does that mean? You see, I canceled x plus 9 and x plus 9. This x plus 9, you're going to make this equal 0. Whatever is cancelling, you're going to make it equal 0. It's going to give me x equal negative 9. So where is the whole? At negative 9. That's the whole. Okay, now I'm going to show you oblique asymptote. How the oblique asymptote works. Okay, so now we are working on oblique asymptote. We did vertical asymptote, horizontal asymptote, and then this one is oblique asymptote. In oblique asymptote, in this case, like I said up here in the definition, m exactly 1 greater than n. What is that supposed to mean? It means, like if I have a function 2x squared minus plus 6x minus 20 over x minus 2, and that's my f of x function. Now, if I'm asking you, do we have an oblique asymptote here? So you're gonna check the greatest degree up here, that term and this term, right? This is x1, that's x2. This is exactly the m, this is m, and that's n. So m is exactly 1 greater than, is exactly 1 greater than n, the numerator. So in this case, I do have an oblique asymptote, so I'm gonna say yes, we have oblique asymptote. But what is the equation for oblique asymptote? You know, oblique asymptote, if I have this, then for example, I have a graph like that, like this. So between them, that's my oblique asymptote. Like this line is my actually oblique asymptote. So what is the equation for this? It's supposed to be a linear equation, mx plus b, the kind of thing, if you pay attention here. So how do I get that? For this purposes, we do synthetic division. What does synthetic division means? In synthetic division, you pick all the coefficients, like 2, 6, and negative 20. You pick those, and then you make something like that, like lines. What is I'm dividing by? I'm dividing by x minus 2, which is going to be positive 2. Like you make this equal 0, then it's going to give me x equal 2. So that's 2. And this thing goes down. These are all the things that we do. Don't pay attention to that. All these things we do, you just have to do it exactly the same way. Now 2 times 2 is 4, and 4 goes here. 6 plus 4 is 10. 2 times 10 is 20. And 20 is 0. So what is the equation for this? And make sure that in synthetic division, if we start with the square in the original equation, like the degree, the exponent is square, the greatest degree in this case, then it goes 1 number down. Like if it's 2x squared, then instead of x squared, I should have the next answer as an x, not square. If I have, for example, 2x cubed plus 6x squared, something, 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 and then I would say, okay, for example, like this, plus 2. I'm just making it up. So if I have the degree 3 and this degree 2, and you know 3m is greater than n, just 1 number greater, then it means we have oblique asymptote. And the equation I'm going to get using synthetic division, but the answer for the synthetic division, I'm supposed to have a x squared because it goes 1 down. Like I should have a 2x squared plus 6x something, something, something like that. So it goes 1 down. So since this is x square, I'm going to go 1 down. It's going to give me 2 as a coefficient, and x, I went down, and plus 10. So this is y equal to x plus 10 is the equation for this function for the oblique asymptote. And that's how you find oblique asymptote. Okay, so what did we do? Let's quickly review really quick. We did domain, how to find domain for the function. We did the range of the function. You switch x and y's. For the domain, make sure the denominator you pick, make it equal 0. Whatever number you get, make the sign chart for it. Pick some numbers here. If you get some y values, then it means it works. If you get undefined or something like a imaginary number kind of thing, then it doesn't work. The parentheses means not included, like I don't have these things. These are not real values. 10 is not even working. We're getting undefined. So I'm just going to tell them this is from negative infinity to 10 works, and from 10 to positive infinity works. But if exactly the 10 would work, then I will make a bracket there and I would say, okay, 10 also works. Range, you switch x and y's and get solve for y, and then make the denominator equal 0. That's range. X intercept, y intercept is right here. Vertical asymptote, make the denominator equal 0 per vertical and horizontal. Please make sure to solve the problem first. End behavior is this, like x approaches negative infinity, then where f of x going? If x is approaching positive infinity, where my f of x is going? Then we have oblique asymptote, horizontal asymptotes. You have to memorize these rules, and that's for the oblique. We do synthetic division if oblique asymptote is there. If m is exactly 1 greater than n, then oblique is there. But how do we find it? Synthetic division. So this is how we got the synthetic division part. Now there is one more thing before I end the video. Increase and decrease. For increase and decrease, it's really you guys have to pay attention here. For example, I have this graph right there. I'm going to erase the stuff that I don't need now. This is the graph, and I'm asking where this graph is increasing, at what intervals. Intervals means x values, right? At what intervals my graphs is increasing or decreasing. So increasing, decreasing means if I pick a point here, pick a point here, pick a point here, pick several points on this one graph right now, right? So I draw a line, I draw a line, I draw a line, I draw a tangent line. This is called tangent line because it touches the graph once. Line. Do you see all these tangent lines are negative slopes? So from negative infinity to all the way positive infinity, right? This means I'm from negative infinity till, not a positive infinity, negative infinity till, this is, I think negative infinity till 0, because it's going all the way up here. It's not crossing this y-axis. So from negative infinity to 0, this is in decreasing. The graph is decreasing. But if I pick these points up here really quick and I draw lines, do you see every line, every tangent line is positive? Then it means from 0 to positive infinity, it's increasing. This is 0, right? My graph is going all the way up here. Or you can say it's 1. Either way, 1 or 0, and going to positive infinity, and it's increasing. The same thing goes up here. For example, I'm starting negative infinity and all the way to negative 5. I'm asking not a y value, just the intervals, just the axis. So from this point to this, it's increasing. It's decreasing, because when I draw tangent lines, they are negative slopes. So it's decreasing. So negative infinity to negative 5, it's decreasing. From here, I can tell this is positive 5, right? The x value right there. And this is infinity. So from positive 5 to positive infinity, I can tell it's a positive slope. It's increasing. So this is how it works. Okay, let's talk about how to write an equation for rational function if you have a graph. So this is my graph, and these are the 3 things you need to figure it out to write an equation for the rational function. X intercept, vertical asymptote, and horizontal asymptote. X intercept means when y is always 0. So what is my x intercept here? If you guys pay attention, this is the only portion right here where the x is negative 3 and the y is 0. So my x intercept is negative 3. I'm just going to write there negative 3, 0. That's what it is. Then we need to figure it out vertical asymptote. Let me write this neat and clean. This is -3, 0. Now find vertical asymptote. Now for vertical asymptote, you can tell this graph is not crossing this +2. And I also can have a vertical asymptote at -2. The graphs are not crossing. So my vertical asymptotes are -2 and 2, right? Then horizontal asymptote. What is my horizontal asymptote? A horizontal asymptote, you can tell it's 0. You see this up here? The graph is not crossing this x-axis. So horizontal asymptote is 0. I mean y equals 0. So how do I make up the equation, put them together? X intercept is going to go on the top for the rational function. So if it's -3, it means it's going to go x plus 3, right? If you have x plus 3, you make it equal 0, it's going to give me x -3. That's why it's x plus 3, opposite signs. This one is vertical asymptote, so we're going to use opposite signs. For example, I have x plus 2 and I have x minus 2. If I make x plus 2 equal 0, I'm going to get x equal -2, which is right here. If I make x minus 2 equal 0, it's going to give me +2, which is right here. So you change the signs. So this is what I got so far for this. Now they said horizontal asymptote is 0, and we know for the horizontal asymptote we use if m is equal n, like the top numerator is the top degree is equal to the bottom degree. Degree means exponent. Then we have a coefficient. I'm just reminding you this one more time. And if m is greater than n, then you have a 0, right? We're supposed to have something like this. That's why our y is equal 0. So I'm gonna go and see if we are getting this. So x plus 3, use FOIL it, distribute x squared, x times this -2x plus 2x, and I have -4. They cancel out. I have x plus 3 and I have x squared minus 4. Now you can tell the top degree is less than the bottom degree, which means m is less than n, and this is not greater, supposed to be less, m less than n, sorry. So if this is the case, then your horizontal asymptote is y equals 0, and which is correct in this case. So my equation is x plus 3 over x squared minus 4. That's the equation of this rational function. If you guys have any questions, please comment below and I will answer it. Thank you, and subscribe, like, share.